Okay, so we are talking about calculating the standard free energy of a reaction. So there's more than one way to calculate the standard free energy of a reaction. In the last video, we looked at how to calculate the standard free energy of a reaction if you're given the standard enthalpy change and the standard entropy change. So this is one way to calculate the standard free energy of a reaction. Another way to calculate the standard free energy of the reaction is if you're given the standard free energies of formation of everything in the chemical reaction. So let's just use the same formula, the same chemical reaction that we've been looking at, the oxidation of ethyl alcohol. So again, this is the same reaction that we did in the previous example where we had the entropy change and the enthalpy change given to us. But in this example, you are going to use the standard free energy of formation of each of these. So what is the standard free energy of formation of ethyl alcohol, of oxygen, of acetic acid, and of liquid water? Again, these would be given or you would look them up. There would be no way for you to know these. Again, it's standard conditions. So this is in a unit of kilojoules per mole, and I'm just going to tell you what all of them are. So here, CH3, CH2OH, and the free energy of formation is negative 174.8 kilojoules per mole. For oxygen, it's the same as the standard free enthalpy of formation, where an element in its reference state, the free energy is 0. So it's 0 kilojoules per mole for oxygen. Again, you're looking this up. For acetic acid, the standard free energy is negative 392.5 kilojoules per mole. And for liquid water, it is negative 237.2 kilojoules per mole. So again, these are the standard free energies of formation that are given in a problem or you're looking them up. So now we're going to use this same formula that we've used for enthalpy and entropy. Now we can use it for free energy. I'm going to say the standard free energy for the reaction equals the sum of the number of moles times the standard free energy of the products minus the sum of the number of moles times the change in standard free energy of the reactants. So we've seen this 3 different times now for delta H, delta S, and now for delta G. Same thing. I've used this same example just so we can see that we're going to get the same answer using 2 different ways to solve it. One thing to pay attention to is that this example that I'm using, the number of moles for all of these is 1. So that's why you're using 1 mole here for N. When you're using other equations and you have 2 or 3 or different coefficients, make sure that you put whatever the coefficient for that species is in here as the number of moles. Okay, so I'm going to go ahead and go through this. So, we'll just do this again. So I'm going to say, remember it's always products minus reactants. So let's do products first. The sum of So that's the products minus the reactants. And I'm just going to put the whole thing down here so I don't run out of space. And this is not really necessary, but I'm just showing you that the free energy for oxygen is 0, so that's just going to make this whole term go away. So you wouldn't really need to show that at all. I'm just showing you so you can see, just to be complete. So when you do this, you should get here for the products, you should get something like negative 629.7 minus, for the reactants, you should get something like negative 174.8. So that should give you a standard free change in free energy of the reaction, negative 454.9 kilojoules. So again, negative number. That means this is spontaneous. And again, there's two different ways to solve for delta G of the reaction. If you're given the delta G's of formation, you can do this. If you're given the enthalpy and entropy of that reaction, you could use this reaction. So look, when we did it this way, we get delta G equals negative 454.7 kilojoules. When we do it this way, we get negative 454.9 kilojoules. These are the same number. So thermodynamics, we're looking at energies, dispersal of energies, heat in chemical reactions, and this is another way to solve for the free energy of a reaction when you are given the delta G's of formation that you're either given in the problem or you're looking up in a book.